Okay, 6.1b, quartic functions, bottom of page 431. Here is an example. Here is the form of a quartic function. It's a fourth degree, and each A, B, C, D, and E are numbers, and obviously your x is our variable. All right, notice the picture on 6.6, A, B, and C. Those are quartic functions. When f of x just equals x to the fourth, we get a function that pretty much just looks like a parabola, but it's flat on the bottom and then comes up. And then when we start adding or subtracting things, it starts doing things like maybe going up like this and just doing wonky stuff. Okay, if you look at the table 6.3, bottom of the page, gives you lots of information. So if you look at the quartic functions down at the bottom, it gives you a couple interesting things there. Number one, it says that if the leading coefficient is positive, okay, so if we have f of x equals negative 3x to the fourth plus 2, or we have 3x to the fourth plus 2. Does a couple different things. If this leading coefficient is positive, then our function is going to give us two endpoints that go up. If this is negative, it's going to give us two endpoints that go down. Okay, it has a degree of 4. The number of turning points is going to be 3 or 1, not 0 or 2. And positive leading coefficient, like I said, it's going to look like the red one, and the end behavior is going to be like that. And if it's negative, the end behavior is going to look like that. And the degree is even. Okay, so the degree, meaning this number right there, is even. Okay, so polynomial graphs. Couple things to just help you understand about that. The graph of a polynomial function of a degree n has at most n minus 1 turning points. Meaning, if we have a function okay, there is our degree is 4, and that is the n. It says if it has a degree n, in this case it's a degree 4, it has at most 4 minus 1 turning points. So it's going to have at the most 3 turning points. So it's going to, like one of these I showed you looked like that. Well, there's 1, 2, 3 turning points. Okay. So my other one I showed you looked like this, where it just kind of went flat there and went up. It has 1 turning point. Okay, so it has 1 or 3. But at most, n minus 1, 3. The graph of a polynomial function of degree n has at most n x-intercepts. So if we have a 4 there, that means we are going to have at most 4 times it's going to cross the x-axis, which basically means 4 answers or 4 zeros. Okay. The end behavior of the graph of a polynomial function with an odd degree. Okay, so if this were a cube or to the 5th power or whatever, one end would open up and one end would open down. So if you remember when I was showing you a cubic function, it looked like this. Okay, and because it's odd, it's a cubed, which is an odd number. One end opens up and one end opens down. Okay, if it is an even degree. Okay, so if it's an x squared, we get a parabola. They both open up or they both open down. If I have x to the 4th and it does this, they both open up, okay, because the exponent is an even number, okay? So if you look at example 3, it just kind of goes over some of that information there. Okay, so let's look at each one of these and determine the number of x-intercepts. So this one has 2 x-intercepts there. This one has 1, 2, because that one doesn't cross. This one has 1. This one has 1, 2, 3. Okay. Number of turning points. We have 1 turning point, 1, 2, 3, and none there, 1 and 2 there. Okay. Whether the leading coefficient is positive or negative. Okay, depends on if it opens up or opens down here. Okay, so the graph shows 1 x-intercept and 0 turning points here for C. And the degree of the function is odd because the end behavior is 1 up, 1 down. The leading coefficient is negative because the left is up. Okay, if it was positive, the left would be down. Because the graph is not a line, the minimum degree is 3. Okay, and I just know it's a 3 because of that shape. I know this is a 4 because of that shape. And I know this is a 4 because of that shape. Okay, so let's look at D. This obviously is going to be a cubic because it looks very similar to the cubic. The graph shows 3 x-intercepts and 2 turning points. Okay, so 2 turning points, that tells me that it's 3. The behavior is 1 end up, 1 end down, so that means it has to be odd, with the right opening up, so the function has an odd degree, and the leading coefficient is positive. Because the graph has 3 x-intercepts, 1, 2, 3, the minimum degree is 3. And I know the degree is 3 just because I know the shape of a cubic function. Okay. All right, so let's look at example 4, and we will call this section done, and then we'll get into some more fun stuff in latter sections here. All right, so using the data from 2000 and projected to 2015, they give you this long function, and that can be modeled to used to model the U.S. unemployment rate with x equal to the number of years after 2000. So graph the function for x values from 0 to 15. Okay, so what they're asking you to do is graph this using that information. Your x value is going to be numbers from 0 to 15. So use the graph and technology to approximate the year after 2000, which U.S. unemployment is a maximum, and the year after 2002 and before 2015, in which it is a minimum. So the 2002 and before 2015 is giving you the interval that they're wanting you to work with there. And basically just asking you basic questions there. So 6.1 is pretty much going to be using your graphing calculator, especially through 1 through 4. 5, 6, 7, 8, you're just going to have to do what we just did for example number 3, looking at those pictures and making that determination. Oh, and up through 9 and 10. 11 through 16, it's just matching the graphs with the equations. Okay, so if you remember that for the most part, that's a cubic, and something that looks like that or flat there is going to be a quartic, and pretty much you've got those two options, quartic and cubics. And you just have to decide which one is which. So it's pretty much just being able to start recognizing the cubic functions and the quartic functions. And when we get into latter sections, we're going to be doing more graphing and actually figuring out the math algebraically. Okay, so that is it for 6.1.